Welcome, geometry students. This lesson, perimeter and area review. Just to review, the perimeter is the distance around the outside, whereas area is the area inside of a figure. Look at the first question. Read the instructions. It says find the perimeter of this figure. This is fairly basic, fairly straightforward. You just say 15 plus 7 plus 8 plus I don't know, plus I don't know, plus I don't know. Find the I don't knows. If this is 12 millimeters and this is 7, this must be 12 minus 7. This is 5. Furthermore, this one down here is 15 plus 8. 15 plus 8, I believe, is 23. So the perimeter is 12 plus 15 plus 7 plus 8 plus 5 plus 23. Perimeter is 70. All you do basically is add up your sides. That's easy when you know the distance of all your sides, but if you look at number 2, I have a problem. I need to find this plus this. I'm going to count blocks to find the distance of these, but then I also need to use the Pythagorean theorem to find that. If you're unfamiliar with the Pythagorean theorem, I refer you back to other videos. I'm going to call this AB. The Pythagorean theorem to find AB is a squared plus b squared will equal c squared. I'm actually going to use a and b in the perimeter. So I'm going to count blocks. This is easier to show on the next problem, but make sure you count blocks and not lines. So 1, 2. This is 12 units, and this is 10 units. So to find the length of AB, it's 12 squared plus 10 squared is equal to AB squared. AB is equal to 2 times the square root of 61. Not a very useful number. If you're interested in what that actually equals, it equals about 15. But you cannot count blocks on a slant. You have to use, and I'm going to use that exact number when I calculate it. So the perimeter is equal to the length of the two legs, 10 plus 12 plus 2 times the square root of 61. You can use the decimal approximation if you want to, but frankly, this makes it more accurate. And do the decimal approximation when you're finished, and I got 37.62 units. I like to include units because you are finding a distance around in this case. Look at the next problem. Read the instructions, find the perimeter. This is what is easier to show when I want to say count blocks. I'm looking for this distance here, and you count blocks. 1, 2. That distance is 6. This distance is 3. This distance is 5. Don't count the lines themselves. A lot of people make that mistake. Think of this as inches. This is 1, 2, 3, 4, 5 inches. This is 1, 2, 3 inches. I also need to use the Pythagorean theorem on this. For this part of it, you cannot count blocks when you're talking about a slanted line. So I'm going to go ahead and recopy that. I know this distance is 1, this distance 3, and so to find the measure of that line, I'm just going to say 1 squared plus 3 squared is equal to square root of 10. My perimeter is, this was 6 units, plus the 3 units, plus the 5 units, plus the length of the slanted side, 6 plus 3 plus 5, plus, whoops, 17.16. And again, they didn't give me units, but because I am trying to find a length of something, I like to include the units. Well, look at number 4. Area. We're going to be focusing mostly on area of a triangle, but also area of a quadrilateral. So area for the formula for the area of a triangle, 1/2 base times height. The most important thing you need to remember in this case is that the base and the height must be at right angles to each other. It doesn't matter what the triangle looks like. It can look like this, as long as you have a right angle. It can look like this, a right triangle. Those are easy because all you're looking for is a right angle between the base and the height. Here we have a right triangle. We actually already did this one. For the perimeter, we found the distance along here is 12. The distance along here is 10. I actually found the distance here, but it's not necessary because when I'm finding the area, it's just 1/2 base times height. I'm going to write the formula. The base is 12. The height or the altitude is 10. By the way, it doesn't matter which one you call the base and which one the height. If you were to tilt this triangle on its side, they would get reversed. So 12 times 10, and all that divided by 2 gives me 60. And this is units squared. By the way, why is it 1/2? Well, if you look at this figure, if you actually complete the box, the area of this box is 10 by 12. That's 120. But this triangle is actually half of that, and that's true for every triangle. Regardless of what it looks like, it's easiest to see on a right triangle, but it's true for every triangle. Fairly basic one. 1, 2, 3, 4, 5. 1, 2, 3. I don't need to know that distance. I just know that the altitude and the base are at right angles to each other. I think that's 7.5, but I better check. Of course I know what it is. Again, units squared. If this were inches, it would be inches squared. What if you don't have a right triangle? No problem. As long as you can have a base and an altitude or a height that are at right angles to each other, then that's sufficient for the area. Actually, I should have read the instructions. It says to find the perimeter and the area. So I'm actually going to find the perimeter first, and that means I've got to find this distance here. So PQ. The length of PQ, I'm going to use the Pythagorean theorem. I've got 2 along the bottom and 3 along the side. So it's 2 squared plus 3 squared is equal to PQ squared. I know you know how to do that calculation. So it's actually the distance formula, which we haven't talked about yet. That gives me the square root of 13. This is also, over here, PO is also the square root of 13. And the distance across the bottom is 4. So perimeter is equal to 4 plus and another 4 plus 11.2 units. Now for the area. The base on this one is the entire length, so that's going to be 4. And then the altitude, I'm just going to count blocks, is 3. So that's a total of 6. 4 times 3 divided by 2. And this is units squared. Look at number 7. Don't panic. This asks for the perimeter and the area. I think I'm just going to stick with the perimeter and omit the area on this one. I said that backwards. I'm actually going to do the perimeter, the area. The base on this one is 4. It's only this portion here, not all the way out. Even though the altitude on this one is outside the triangle, doesn't matter. The altitude is 1, 2, 3, 4, 5, 6, 7, 8. So the area, 1/2 base of 4, altitude of 8. Is that 8? 16. I got time to do the parameter. I'm going to find CE first. CE. Is equal to 2 squared plus 8 squared. That's CE squared. Square root of 68. And then the bigger one, it's a little bit more complicated. I'm trying to find the distance of CD. And I'm going to use this triangle here. Well, I know this distance is 8, so CD is equal to 8 squared plus this entire distance down here, which is 6 squared. And of course, is CD squared. CD is equal to 10. Add them all together. 10 I just found. Square root of 68 I just found. Plus, don't forget the 4. And you get 22.3. And that's that.